This is a re-recording of the CISC124 lecture from Friday morning. We had some audio issues in class today. The audio cut out after a few minutes from the live stream, and it also cut out from the recording of the lecture. So I'm redoing the lecture offline. So the topic of today's lecture is from Python to Java. I'm going to show you how to do some basic programming tasks in Python. And then show you what those tasks look like in Java. So a Python program starts running from the first line of a script, right? And that means that a program can be only a single line long. So for example, here's the standard hello world program in Python. And obviously, if you run this in a Python interpreter, it'll print out the string hello world. Now in Java, a Java program always starts running from a method called main. A main method belongs to a class. It can also belong to an it can also belong to an interface, but for our purposes right now, it belongs to a class. And the main method, for it to start running the program, it has to have a specific form. Right, so here you've got this, you can see that the Java program to print out the string hello world is much longer than the corresponding Python program, right? You have to make a class, right? So here we've got a class called hello world. Inside that class, you have to make a method called main, and this method has to be written the way I showed on slide. Inside the main method, you see that instead of print, we have to write system.out.println, and then in brackets, the string that you want to print. So right away, you can see that a small Java program tends to be a lot longer than the corresponding small Python program. Okay, now there's actually two legal forms of the main method. Right, so on the previous slide, right, we had a public static void main string and then ... The other more common form is public static void main and then string square bracket. Right, it's not important that you know what the ... or the square brackets means. We'll get to that next week. But there are two different forms of the main method, and you can use either form. So I'm just going to jump over to Eclipse and show you how to make this hello world class with a main method. Okay, so in Eclipse, you can see here I've got the CISC124 notes open. Now, you don't have this package called lectures in your distribution of the notes. If you want to make your own package, though, it's easy to do. Right, on the SRC folder, right-click your mouse, right, choose new, and then package, right, and then you type in the name of the package here. So if you want to reproduce what I'm showing you here, you would just type in lectures, and you would press finish. I can't press finish because I already have a package called lectures. You'd press finish, and it would make the package here, right? And so I'm going to make the hello world class in the lecture package. So again, so right-click on lectures. So go to lectures, right click, new, class. Right, so here you want to give the class name. So that's going to be HE hello world. So the H and the W are capitalized. I want a main method in this class. So you can check this box here and the Eclipse will create a main method for you. And you just press finish. And there you can see Eclipse has created the skeleton of the hello world class for you. So we can just replace what Eclipse has written there with whatever we want. So I'm just going to write system.out println and then hello world in quotes. There you go. So you can see when Eclipse created the main method, it gave us the second form of the main method. If you run this, so you can save this, you can either hit Control S or use the little disk icon up here or use File Save. and then you can run it. When you run it, you'll see in the console down here, the console might appear somewhere else, but you'll see that the string hello world is printed out. You can also see that it's gone to the next line, right? So println is the Java method that prints what it's given, and then it goes to the next line. Now, the first form of the main method, instead of the square brackets, you use 3 dots, right? So if we do that and save that and run, it also works, right? Now, what happens if I don't use either one of those 2 forms of the main method? So for example, I still have a method called main, but now it's only taking in a single string as its argument. If I try to run this, the compiler will actually, the Java runtime will complain, right? So it's going to complain that, hey, I can't find this main method, right, in the class. There is a main method here, it's just that it has the wrong signature, right? So the type of parameter is string instead of an array of string, right? Or string ... Right, so the form of the main method has to be one of the 2 in order for your program to run from that method. Okay, so you can see that there's in this little program, there's actually quite a lot that's different than Python. So we made a class called Hello World, right? So in Java, a class name should always start with an uppercase letter. It's not allowed to have any spaces, and you should use what's called upper camelCase for a multi-word class name, right? So if you have a class name that's made up of multiple words, then each word should begin with a capital letter. You're allowed to use underscores in a class name, but you should generally avoid it unless you have some unusual sequence of characters that makes camelCase awkward to use. Okay, so what else is different compared to Python? So at the end of that, at the end of the print line statement, we've got a semicolon in Java. So the semicolon is required in Java, right? In Python, you're allowed to end a line with a semicolon, but you don't have to, and most programmers don't. In Java, any single line, well, any statement that looks like this has to end with a semicolon. In Python, you know that strings are indicated by, or string literals are indicated by single quotes, right? Similarly, you can use double quotes. Python lets you use triple quotes, so you can use 3 single quotes or 3 double quotes. Right? And those all correspond to Python strings. In Java, a string literal is always delimited by double quotes, right? So a double quote here and a double quote at the end. And there's actually an error on this line. Oops, sorry. Right. I told you just a second ago that all Java statements should end with a semicolon, and I forgot to do so. There we go. Okay, so that's now correct. Now, Python's print function is actually pretty neat. So if you want to print out multiple things separated by a space, you can tell the Python print function, you just list out the things you want to print separated by commas, and Python will print out everything. Will print out the items with a space between them. And then it'll add a new line at the end of the line. Right, so print 2, comma, the string plus, comma, the number 3, comma, the string equals, comma, the number 5. Outputs 2 plus 3 equals 5 with spaces in between everything. Now, you can't do that in Java. So in Java, the print and println methods, they only accept a single argument. Right? So in other words, you have to compute the thing that you want to print and then give that to the println or print method. Right? So in this case, we can use what's called string concatenation to compute the string that I want to print. We're going to talk more about strings next week. So this is just showing you how you can do it. Right? So if I write something, so 2, this is an integer value. plus sign and then followed by a string, Java will use what's called string concatenation to join these two things into a new string. Right, so it'll convert the two. Well, it won't convert the two. It'll compute the string corresponding to 2, and then it will join that with the string space plus space. Right, and that produces a string. Right, so 2 plus string plus produces a string, and then plus 3, well, that's string concatenation again, right? So that's a string concatenated with an integer. So Java will compute the string corresponding to a string, to 3, and then concatenate all of this together, right, to produce a new string, plus the string equals, so that's string concatenation again, right? And then all this as a string, right, concatenated with the number 5. So Java converts the string corresponding to 5 and then joins everything together, right? And you get the string 2 space plus space 3 space equals space 5. Right, and if you want to, you can just go into your Hello World program and put that copy that line into Eclipse and run it to see what happens. Right, if you take out the space, you should take out the spaces and see what happens as well. Okay, so Python variables have no type associated with the variable name. Right, so in Python you can write something like s equals the string hello world, and then right away you can store something else that's not a string in the variable s. Right, so for example, I can store the number 123 or 123 also in the variable s. Right, or I can make the list 123 and assign that to s. Right, and lists in Java, lists in Python, right, you can put whatever you want into the list. Right, so in a Python list, I can put in the number 1 and then the string ABC, and then you can put in another list if you want. And in fact, you can, typo there too. Right, so I can put in and once again, you put in a number followed by a string followed by an empty list. Right, and you can put whatever else you want into the list as well. Okay, so this is one of the big differences in Java. In Java, a variable has a type, right? And so you have to say what the type of the variable is when you declare the variable name for the first time, right? So the first time I want to use the string s, the variable s, right? I have to say that the type of the variable is capital S string, right? And then I can assign a string literal to the variable s. So PowerPoint is automatically converting certain characters on me. Right. So once again, so I have a variable s. Its type is declared to be string, and so that means I'm allowed to store a string value in s. Right. Once you make a variable and declare its type, you can't change the type, right? And a variable can only hold values of the declared type. So if I use this variable s somewhere in this fragment of code, right, I can only store strings in that variable s, right? So for example, I can't store the number 123 in that variable s. To store the number 123, I have to make a new variable, right? So I have to use a different name. So here I'm using t. And I have to declare its type as well, right? So for integer values, the default type that you would use would be little I int, right? And for a list in Java, so Java lists are very different than Python lists. So as I showed you before, Python list, you can put whatever you want into the list. So Java lists are much more restrictive. So in a Java list, the elements all have to have the same type. So you have to tell Java what type of element do you want to store in list, right? So here it's list less than sign, big I, integer greater than sign. So that makes a list that can hold some integer values, right? There's also no array literal in Java, right? So I can't write down there's no way for me to write down a list and its contents like you can in Python, right? Using the square brackets. So that doesn't work in Java. Instead, in Java, you actually have to create a new list, right? So here I'm doing that by writing new array list, less than, greater than, round bracket, round bracket. So that actually calls what's called a constructor for the array list class, and that produces an array list object. Once I have the object, I can go ahead and add some elements to the list, right? And we'll see this in greater detail next week. When you create variables in Java, you should name them following the convention described here, right? So a Java variable name should always begin with a lowercase letter, and it should contain no spaces, right? There are exceptions to the rule. If you're making constants, then the rule is different, but again, I'll show you that next week, right? For now, when we're creating variables, they should always begin with a lowercase letter. If your variable name is made up of multiple words, then you should use what's called lower camelCase, right? So in other words, the A list is a multi-word variable name. So the first letter is in lowercase, right? But the beginning of every other word in the name should be capitalized. Okay, comments in Python. So a comment in Python always begins with the hashtag or pound sign, right? You know that a comment always ends the line that it's on, right? So here I've got a line that's just a comment. There I've got a line that's just a comment. Here I've got a comment at the end of the line, right? So it comes after the statement final value equals p times whatever, right? So that's fine too, right? If you're reading this slide and wondering, is there an error in this number? The answer is yes, there's an error. We'll get to that in just a second. Okay, so Python comments are what are called inline comments, right? So in Java, an inline comment starts with // instead of a hashtag or pound sign, right? And otherwise they behave exactly the same as a Python comment, right? So there's a one-line inline comment. There's a second one-line inline comment. And here there's an inline comment that's after the statement of the line. Java also has multi-line comments. So a multi-line comment starts with /* and it ends with the first occurrence of //, right? So that's important to remember, because sometimes you use the multi-line comment to comment out a big block of code. But if that big block of code has another comment in it, right? So I try to comment out all of this code by writing /* and then / at the end. The compiler will complain because it'll see /* and then it'll see // so it will think that ends the comment, whereas really the end of the comment was supposed to be here, right? So you have to be a little bit careful about that, right? So it starts at /*, ends at the first //, right? And you can put whatever you want otherwise in between the /* and //, right? You can even insert one of these into the middle of a statement somewhere, right? So here I've got a comment, right, after the equal sign, but before the rest of the assignment statement, right? Before the value that I want to assign to final value. That's occasionally useful. Here it's just illustrating that you can in fact do that, right? Now, there's something funny about this code, right? So let's run this in Eclipse. Okay, so here I've already created a little program called compound interest, right? So for those of you who don't know, that formula is the compound interest formula, right? R is the interest rate, right? That number 10 is the number of years that I'm compounding the interest over, right? P, that's how much money I start out with or how much I invest, right? That's supposed to be the interest rate in percent. So here I've said it's 1.25. Now, if I run this program, right, so this is $100 compounded at 1.25% over 10 years, right? So 1.25% is approximately the best interest rate you can get on a regular savings account in Canada at the moment. So if I run that, it says that after 10 years, I'll have about $300,000 if I start out with $100, right? Which doesn't sound right, right? If it was, well, I probably wouldn't be here giving this lecture. I would have invested $100 10 or 20 years ago and be happily retired at this point. Okay, so something's going on here. The problem is this interest rate, right? That's not 1.25%. That's actually 125%, right? So what you need to do is you need to divide that value by 100, right? And now if I run it, I get $113, which is the correct answer, right? And it also shows you that you're not going to get rich very quickly by investing your money in a savings account at this point in time, right? Now, when I was, I guess, a little younger than you, the interest rate that you get on a savings account was quite a bit higher. So you could get interest rates as high as 6% at some point in time. That's a lot more interesting, right? You almost double your money in 10 years, right? So it used to be the case where you could, you could double you could get a decent rate of return on your investments just from a savings account, but that's no longer the case, right? In today's financial environment, interest rates on savings accounts are very low, right? And it takes you a lot longer to get the same amount of money returned back to you. Okay. Right. So 125%, not 1.25%, right? Okay. So notice that there's in Java, I had to use this method called math.pow to compute 1 plus r raised to the power 10. Right? So there's no exponentiation operator in Java, right? You have to use this method instead. Right? We'll be talking more about calling methods in next week. Okay, so a literal is any value that you can write down, right? So in Python, the literal capital T true is the literal that corresponds to the Boolean value true. Boolean values are sometimes called logical values as well, right? The number 1 is an int literal in Python. 1.0 is actually not a double literal. It's a float literal in Python. And hello inside single quotes is a string literal. But the actual type is str in Python. Right? The square bracket, that's actually a list literal in Python. Okay, so in Java, there are literals as well, and they have types, right? So the word lowercase t true and lowercase f false, those are true-false values, and their type is a little b Boolean. Any number that does not include a decimal point is probably an int. Any number that does include a decimal point is probably a double. Anything inside double quotes is a capital S string literal. And there is no list literal in Java, right? So there's no way to write down a list and its contents in a simple way in Java. Okay, so there's Java has a notion of primitive and reference types, right? So in Python, everything is a reference type, right? You may or may not have been taught that in your previous courses, right? But values are actually references to objects. And I'll show you an example of that in a moment. Java has reference types. Okay, so Java also has reference types. You can identify a reference type by looking for things that start with capital letters, right? So big S string, that's a reference type. Big L list, that's a reference type. Big A array list, that's also a reference type, right? So classes are user-defined reference types, right? So things like string and list, or well, string and array list, those are actually examples of classes. And a class is just a user-defined reference type, right? And that's why I told you your class names should always begin with a capital letter, right? So Java programmers are used to looking for things that begin with capital letters to identify reference types. Unlike Python, Java also has primitive types. Okay, so any type that begins with a lowercase letter is one of the primitive case types. Is one of the primitive types, right? Unless you are not following the Java convention and you decide to name your classes starting with a lowercase letter, right? So you should always name your classes with an uppercase letter because your classes are actually reference types. Something's going on here. Oh, wait. Okay, so I'll come to that in a second. In Java, there are 8 primitive types, right? And you can't add any more, right? So these are built into the language. So the type Boolean, those are the true false values. Java has 5 integer types, right? Mostly we'll be using int. Sometimes we'll have to use long, and we'll also be using char. Byte, short, don't show up won't show up in this course, and they're somewhat uncommon in most Java code. Your floating point types will mostly be using double, but we'll be using float in many of the examples as well. Right, so double is what roughly corresponds to a Python float. Int is what roughly corresponds to a Python int, and Boolean is what corresponds to I think the bool type in Python. I'm not 100% sure on the actual type in Python. Okay, so what is this? So what is it exactly that a reference variable So what are references exactly, right? So a reference variable stores references to objects, right? And in Python, all variables store references, right? So when you write x equals 1, you're not actually the variable x doesn't actually correspond to the number 1, right? It's a reference to some object that represents the value 1, right? When you write 1.0, right, or y equals 1.0, right? Y does not have the value of 1.0, right? Instead, y is actually a reference to some float object, right? That float object happens to represent the value 1.0, right? If you write s equals the string hello, then s isn't string hello. In fact, what it's storing is a reference to a string object. That string object happens to represent the string hello. Right, so I'm just gonna, in class, I drew a picture on the chalkboard. Here is the same picture, I think drawn a lot better, right? So this, what I'm showing you here is a very crude model of computer memory, right? So you can think of computer memory as just being a big list or table, right? One column. Well, here I've got it, it's actually 2 columns. There's a variable name here. Here is what's being stored in memory, right? On each line, you can store one thing, right? So you can see here, up here, there's this int object. Now, I don't know what's inside of an int object, so it's drawn as multiple lines, right? Indicating it takes up more than just one line in memory, right? But that int object here represents the value, the int object 1, right? There's another object here, right? So there's a float object, right? I don't know what's inside the object, so I don't know exactly how it's represented in memory, right? But I'm going to write down number 1.0 to indicate that it represents the number 1.0, right? And here you have a string object. Again, I don't know what's inside the string object exactly, but I'm going to write the string hello to indicate that it represents the string hello, right? Notice that all the objects seem to take the same amount of memory. That's not true, right? It's almost certainly not true, right? But it's just the way I'm drawing them, okay? Now, the variables x, y, and s, right? So here we have x equals 1, right? So what's stored in memory beside the box labeled x is not the number 1, right? It's a reference to that object here, right? So I'm showing that as the phrase reference to, and then an arrow pointing to the object that the variable x actually refers to, right? Y is not the number 1. It's a reference to some object that represents the number 1. And S is not the string hello, it's a reference to some string object that represents the string hello. Right, so those are reference types, and everything in Python is a reference type. Right, every variable refers to something in Python. Now, compare that to Java and Java's primitive types. Right, primitive type variables actually store a primitive value. Right, so in Java, if you write int x equals 1, then x really stores the value 1. Right, if you write double y equals 1.0, then y really stores the value 1.0. Java also has reference types, right? So capital S string, that's a reference type. So the variable S is a reference to a string object that represents the string hello, right? So in a picture, right, it's very different than the corresponding Python program, right? Somewhere in memory, there's a string object, right? Again, I don't know what's in it, but I'm going to write double quotes hello to indicate that it represents the string hello, right? So the variable S is not the string hello, it's a reference to the string hello, right? But X and Y are primitive types, right? X is an int, so it really does store the value 1. Y is an int, it really stores the value 1.0, right? So that's the difference between a primitive and reference type. Now, there's an implication with all of this in these pictures it's not quite clear in these pictures. So in each row of this of this picture of memory that I'm showing you, you can only store one thing, right? So here I can only store the value 1, right? I can't store the value 1 and 2 and 3, right? I can store the value 2 here, but I have to overwrite the 1, right? Similarly here, right? I can store the value 1.0, but I can't store 1.0 and 3.0 and 5.0, right? I can store a different value here, but I overwrite the value that's sitting here. Now, each one of these lines, that represents a fixed amount of memory, right? So all of the primitive types occupy a defined and fixed amount of memory, right? The actual amount of memory that a primitive type occupies is different for each of the primitive types, right? But it's always fixed, right? And in Java, it's always a well-defined amount, right? Now the problem, if you think about it for a second, there's an implication of all this, right? You have a finite amount of memory to represent a value, which means you can only represent a finite number of different values, right? So what does that mean? That means if you use a primitive type like int, right, there's going to be a maximum and a minimum value that you can represent because you can only represent a finite range, right? So the most negative value that you can represent using a Java int is stored as the constant big I integer dot all caps min value, right? Here's an example of where you would use an underscore, right, in a multi-word name, right? Because you can't use upper camelCase when everything is in all caps, right? So when you see something in all caps in Java, it almost certainly corresponds to a constant of some kind. The largest value that you can store in an int is represented by the constant integer.max value, right? And so the numbers are big, but they're not huge, right? So max value is roughly 2 billion, right? And min value is roughly minus 2 billion, right? And those are all of the values that you can represent with int, right? So from minus 21474836648 up to including 21474836647, right? But you cannot represent a value bigger than that in int with an int, and you cannot represent a value less than that using an int. Okay, so an int literal is any number that you can write down without using a decimal, right? So anything you write down, any number that you write down with no decimal point in it is probably an int, unless it ends in a capital L or a lowercase l, right? If it ends in a capital L or lowercase l, that indicates a long value. It's a compile time error if the number you're writing down, if your literal is outside the range that an int can represent. Okay, so in this example here, -1, that's an int literal, right? 99, 98, 1 and 0, Those are all int literals, right? If you have a long literal that you want to write out, you're allowed to use underscores in between the digits, right? You're not allowed to use an underscore at the beginning or end of the number, but in between digits, you can use an underscore to indicate, to make the number easier to read, right? If you know what a binary, octal, or hexadecimal value is, it turns out there are ways to write those as int literals, but we're not concerned with that in this course. You can easily look this up online to find out how to do it. Okay, so when you do arithmetic with two int values, you always end up with another int value. Okay, two ints, right? You do some arithmetic with them, you always get back an int. The same is true if you have a single int value, right? So if you write negative some number, some int number, then you get back an int. If you write positive some int number, then you also get back an int. Now, that's fine, right? Addition, subtraction, multiplication, that all seems to make sense, right? But what happens in division, right? So when I divide two int values in math, or two integer values in math, you usually don't get back an integer, right? You get back some real number. In Java, you get back an int. And so Java division is what's called truncating division, right? So you do you compute the quotient and then throw away everything after the decimal place. Right, so here we have values, x is 1, y is 3, z is 13, right? X plus y, that produces an int because x and y are both ints, and you get the int 4. Right? X minus y, they're both ints, so you get an int value, and the value is minus 2. Now let's look at x divided by y. Right, so x divided by y is 1 divided by 3, right? Mathematically, that's 0.33333. You throw away everything after the decimal point, so you get 0. Z divided by y is 13 divided by 3, right? Mathematically, you get 4 and a bit, right? So you throw away the and a bit part, and you get 4. Right? X plus y plus z is 17. 17 divided by 3 is 5 and a bit, so you throw away the and a bit, and you get 5. Right? The same thing happens for negative numbers, right? If you have like negative 4 divided by 3, that's negative 1 and a bit. So you throw away the and a bit and you get negative 1. Right? That's truncating division. It's called truncating division. In Python, you can use // to divide two ints to get another int value. In Python, it's not truncating division. Instead, it rounds towards 0, right? Which behaves differently than Java for negative numbers, right? Or for negative quotients. Right? Java always rounds towards minus infinity. Python rounds towards 0 when you use Python's // operator. Now, what happens if you do some arithmetic with two int values and you end up with a value that's greater than integer max value, right? So, for example, if I take the integer max value, right, x, and add 1 to it, what happens? Well, it turns out in Java, you don't get an error. Instead, what happens is the value wraps back around to the other end of the range, right? So in other words, if you add 1 to integer max value, you wrap all the way around to integer min value, right? So it's like the range of int values is cyclical, right? Or circular, right? If I take x and add 2 to it, right? Well, adding 1 takes me to integer min value. So adding 2 takes me to integer min value plus 1, right? And if I take x and add 3 to it, well, adding 1 takes me to integer min value, right? Adding 2 takes me to integer min value plus 2. So adding 3 takes me to integer min value plus 2, right? And it's worth running this in Eclipse as well. Right, so I've got a little class here called int limits, right? Here I've got x as integer max value, and I'm just going to print out x plus 1. Right, and you'll see that it prints out that is in fact integer min value. Right, now remember it ends in an 8, okay? So if I add 2, oh wait, why don't I just do it this way? Just copy that, paste that in. So 2 and 3. right? So there's integer min value. That's integer min value plus 1, integer min value plus 2. Okay, now the same thing happens if you do arithmetic with two int values and it produces a value that is less than integer min value, right? So it wraps around, but this time it wraps around to the other end of the range, right? So you end up at on the high positive side of the range, right? So if I start out with integer min value and subtract 1, right, we wrap around to integer max value, right? If I take x minus 2, I get integer max value minus 1, right? And x minus 3 is just integer max value minus 2, right? And once again, right, in Eclipse, I can just change this to integer min value, right? Minus 1, minus 2, and minus 3. Sorry. Right, so you can see that's integer max value. That's integer max value minus 1. And that's integer max value minus 2. Right, so there's this, so the behavior of Java ints is very different than what happens in Python. Right, in Python, if you took that number and subtracted 1 from it, you would get the mathematical result. Right, so in other words, Python ints don't exhibit this wraparound behavior. Right, now when you perform an arithmetic calculation using integer arithmetic, right, and the result of the calculation exceeds the range or is outside the range that your integer type can represent, then that's called integer overflow. Right, now in Java, wrapping occurs. Right, so I just showed you how Java behaves when you go beyond integer max value or to the right of integer max value or less than integer min value. Right, other languages, something else happens. Right, in particular, more modern languages, they will some of the more modern languages will let you choose what happens when integer overflow is detected. Right, but in Java, the wraparound happens and it happens silently. Right, so you get no warning and you get no error. Right, now integer overflow happens to be the cause of many famous or infamous events. Right, and you can just click the links in the PowerPoint to learn a little bit more about some of these events. Very quickly, Ariane 5 was the European Space Agency rocket that exploded shortly after liftoff. Deep Impact was is a NASA satellite that was sent was sent to a comet, and it fired a projectile at the comet to see what would happen. Right, they wanted to know what the comet was made out of, and lots of other things. It actually completed that mission, and then it was still functioning, so they sent it off to do something else, but they ended up losing contact with the satellite. That was caused by integer overflow. Therac 25 was a radiation therapy device. So it would dose patients with radiation, I think for cancer. Although I'm not 100% sure on it if it was cancer or not. But anyway, it turned out to have several software bugs. One of which was integer overflow, and it ended up causing several patients to be overdosed with radiation. Some of them massively. 3 people ended up passing away because of radiation poisoning. The year 2000 problem was caused because banks and other financial institutions used to store years using only the last 2 digits. Right, so 71, for example, would represent the year 1971. As the year 2000 approached, people realized that the year 00 could be the year 2000, but it could also be the year 1900, which is an off by 100 error, which is a problem if you're a financial institution. And a lot of money and effort was expended trying to fix software that had this problem. And I'll leave you to look at the other links on your own. I think that's where we stopped today in class. And so I'm going to end this lecture here, and we'll pick up from this slide on Monday.